Yes?
It was saying that y equals natural log of parentheses tangent squared parentheses x.
Tangent squared x.
And then ask for x equals.
Like this?
Yeah.
Okay, so we want to find when it's discontinuous. Anything else?
No, that was all.
Are we given any specific interval, domain, anything?
No. It just asked me for the x and then asked me to graph it. And there was some like saying like the n, you could put n if it was I think infinite discontinuities. That was the one with like n in it. It was like n 5.
Right, so let's talk about it. So this is the only information we have, correct? Is there anything else? No. Okay, so we know that natural log, like any log, is defined only for strict positive numbers. Pretty similar with the square root of x, but here I can plug in 0, but here I cannot. So this quantity, which is tangent squared x, is definitely a number greater than 0. But there is a potential problem. So because this is always a positive number, right? But it could also be, no, it could never be negative because it's squared. But it could also be, and that will create a big problem. It could be, right, that's the problem. It's not a problem that it's always positive, but if it is 0, then it's a problem because I cannot plug in 0 in natural log. So all I have to say is this: solving this equation, which is basically solving this equation, will give us the restrictions. It will give us, in other words, the discontinuities of this function. But tangent x equals 0 is the same with sine x over cosine x equals 0. And when is a fraction 0? Only when the numerator is 0. And now I have to solve this equation. On the unit circle, where do we measure sine? On the x-axis or on the y-axis? Good. So because we measure on the y-axis, these are the points where sine is 0. At this point, so sine x equals 0 implies x equals 0 plus 2. I use k, but use n. Since your book says n, that's fine, doesn't matter. 2n pi, where n is 0 plus or minus 1 plus or minus 2, any integer. And the other option is pi 2 pi k, 2 pi n. Let me put 2 pi and n. That's the correct, it doesn't matter, but that's the correct way of writing it. 2 pi n. Okay? Where n is any integer. Now, these can be condensed as simply pi n. So x is pi n. Let's see if we get that. If n is 0, I get 0. If n is 1, I get this. It's pi. If n is negative 1, I get this. It's negative pi. If n is 2, I get this. If n is negative 2, I get this. If n is 3, 1, 2, 3, I get this. So this is the solution, of course, with n equals 0 plus or minus 1 plus or minus 2. These are all discontinuities of this function. Is that clear? So the condition was coming back. Let's discuss this one more time just to make sure. The problem is natural log, because natural log is not defined for anything I want. It has to be defined, and it's defined only for strictly greater than 0. And you can say that's wonderful. Tangent squared is always positive. True. But what if it's 0? That's the only problem. So tangent squared means 0 means tangent equals 0. Of course, these are all not equal to, right? Because we're talking about restrictions here. Oh, that's another one here. Okay? So, or you can say at these points, x values, at these x values, the function is discontinuous. For sure, it has an infinite discontinuity. So we solved. I don't care for tangent. I changed it into sine over cosine. I know a fraction is 0 and 1 at the top is 0. And always keep it as simple as possible. You don't need tangent, cotangent, secant. Go back to sine and cosine. That's the simplest possible trig functions. So sine cannot be 0. Sine is 0 here, is 0 here, 0, 0. It's 1 here, and it's negative 1 here. So 0 plus 2 pi n, pi plus 2 pi n. But you don't have to separate it. You don't have to keep two. Both are correct. You can. This is the correct solution. But you can condense them into this one. These two solutions are here. Does it make sense? Is it clear? So the problem was for tangent not to be 0, because then we cannot apply log to it. We cannot apply log to 0. Very good question. Anything else from WebAssign or anything else you have before we start this? Anything else? Did you work on anything else that you have? Yes, please.
I have one.
Yes, I'm ready. Excellent. Thank you very much. Okay. Okay, so we have f of x. Didn't we do this problem last time? Maybe I'm wrong. We want to make this function continuous everywhere. Did we do this problem or am I dreaming?
I think the one we did had C in it, and
Okay.
it's just two functions.
Okay, so we did not do this one. Right? That's fine. Very good. So we want to make this function continuous everywhere. And like before, I will have to write this sentence first. First, I want to simplify this. So x squared minus 4 divided by x minus 2, the top factors how?
X plus 2 minus 2.
And I will simplify, but not before I state the restriction x not equal 2. But there is no need, actually, because x is not 2. So I will simplify. So the simplified form of the first quantity is x plus 2. I will rewrite the function as x plus 2 for x less than 2, ax squared minus bx plus 3, and for x minus a plus b for x greater than or equal to 3. Is this okay so far? So that was my first step. There is nothing I can do to the other two pieces. I can only simplify the first one. I cannot do anything else to the other two. Now, in step number 2, I will have to write that x plus 2, ax squared minus bx plus 3, as well as 4x minus a plus b are as polynomial functions. Yes. Everywhere. On negative infinity to infinity. What could go wrong here? In which situation this function will not be continuous? X plus 2 is continuous, the middle is continuous, the last one is continuous. In which situation this function will not be continuous? If it is not continuous, where? Yes? And at? Right. So that's all I have to study. So continuity at x equals 2. What has to happen at x equals 2 for this function to be continuous at x equals 2? I pretend I didn't hear. The limit as x approaches 2 from the left of, excellent, must equal, awesome, from, awesome, and must equal f of 2. Great job. That is true, right? A function is continuous at a point if the function value and the limits left and right all exist and are the same. Agreed? Perfect. So now please give me the left-hand side. Calculate the left-hand side and tell me what to write. On the right-hand side, you will say, very good. In the middle, you'll say, very good, minus 2b and plus 3. Do we all agree? And now for f of 2, which branch do I use? Top, middle, bottom. Correct. So I have 4a minus 2b plus 3, which is the same, so I'm not going to write it again. So this is what type of equation? And you have to say linear with 2 variables, correct? Let's clean it up and put everything in correct order. 4a minus 2b equals 1. This is equation A. 4a minus 2b equals 1. I move 3 to the other side. Now here's a question for you. Is it sufficient? Is this sufficient to solve for a and b? I have 2 variables, 2 unknowns. How many equations I need? 2. Good. So as we discussed, I have to continue with item number 4, continuity at x equals 3. So what has to happen at x equals 3? Very good. As x approaches 3 from the left, which branch? Very good. Awesome. Ax squared minus bx plus 3 must equal limit as x approaches 3 from the right, from which branch? Very good. 4x minus a plus b must equal f of 3. Awesome job. Good. Can anyone give us the left side? We plug in 3. Very good. 9a. Very good. Plus 3 must equal 12 minus a plus b. And I took this away too fast. F of 3, top or bottom? I'm sorry, middle or bottom? Right. So I still have 12 minus a plus b. I'm going to say same and not have to write it again. I clean this up, moving a, moving b, and moving 3. Moving a, moving b, and moving 3. So I'm adding, so 10a. I'm subtracting, and I'm subtracting. This is my equation B. Now, what do you think I'm going to do with A and B? And the answer is create a system of 2 linear equations in how many variables? 2 variables. So 4a minus 2b equals 1 and 10a minus 4b equals 9. System of 2 linear equations in 2 variables. Now I have to dig deep and ask myself, how do I solve this? Excellent. So Chris said multiply the first equation by -2. Why did he say that? To eliminate b. Awesome. Well done. Well done. So the new system is -8a plus 4b equals -2 and 10a minus 4b equals 9. And as planned, b goes away 2a equals 7. Or a equals 7 over 2. With a being 7 over 2, we go back to any of the equations. Let's say I go back here. Replace a by 7 halves. 4 times 7 halves minus 2b equals 1. I'll simplify. So this is now 14 minus 2b equals 1. I move 14. Negative 2b equals negative 13. So b equals 13 halves. So then the solution of the system is 7 halves, 13 halves. So now the function will be like 5 page earlier, okay, x plus 2 for x less than 2. 7 halves x squared minus 13 halves x plus 3 between 2 and 3. And finally, 4x, but then I have negative a, which is negative 7 halves, plus b, which is 13 halves, which will be 6 halves, which will be 3, for greater than or equal to 3. Very nice problem. It's from Web Assign. Good. Any questions on this? Any questions on this? Is there anything else that you would like to go back to? Anything else? Okay, so now please select from here. Anything you like. If there is something you know, we don't have to select it, we can move on. If there is something that we need help with, let's do it.
Number 1.
Number 1, so let's look at number 1. So we have limit as x approaches 0 from the right, the square root of x cosine pi over x. Like with every limit, we have to plug it in first. And when we plug it in, we realize that this approaches awesome, and this approaches not in the least, right? Remember the graph of 1 over x. You cannot say that when x approaches 0 from the right, this is 0. You can't say that, right? So this does not exist. And now I'm going to ask you how much is cosine of does not exist. So obviously we are not on the right track, meaning we can determine the limit like that. But what is the other options? No, because we have a method. Yes?
Use the squeeze method.
Of course. The squeeze theorem is the answer because cosine, thank you very much, is a bounded function between which values? Very good. -1 is the smallest, 1 is the largest. Of course, I need to build this function in the middle, so I'm going to multiply all 3 sides by the square root of x. But I have to make sure that this is a positive number. Of course, the square root of x is a positive number. And I have to make sure that it's not 0. Of course it's not 0, because x approaches 0, we really mean it. X is not 0. Because if we're not sure of that, we cannot multiply, right? So we have to make sure that that is correct. Cosine pi over x less than or equal to the square root of x. So this is basically the first hypothesis of the squeeze theorem. We squeeze the function between 2 other functions. Now let's call this f of x, and let's call this g of x. And now in step number 2, what do we need to do? Excellent. Excellent. We have to determine the limit of f of x and the limit of g of x. So limit as x approaches 0 from the right of negative the square root of x and the limit of the square root of x as x approaches 0 from the right. If these two exist and happen to be the same, then we know the limit of the function that we are trying to determine. Do they exist? What is it? Very good. And the other one? Very good. So from 1 and 2, by the squeeze theorem, what do we conclude about limit? As x approaches 0 from the right, from the square root of x cosine phi over x. Equals what? How much? Of course. If it's squeezed between two functions and the limit of the top and the bottom is 0, then the limit of the function has to be 0. And no, you cannot conclude that 0 times something that does not exist is 0. You cannot. Good. Any questions on this? Okay. Next problem that catches your eye. Yes, please, Eddie.
D, 5D.
5D. Let's jump to 5D for now. Very good. Any questions on number 1? Okay. In 5D, we have limit as t approaches 0 from either side, 1 over t minus 1 over t plus 1. Okay. Any suggestions? And you should say, well, plug in 0. Yes, but I'll be in big trouble if I do. Once I do, I realize that I have something that I can't deal with as is. And I cannot even separate the limit into two limits because the limit of the first function as well as the limit of the second function don't exist. Those limits don't exist. I cannot separate. I cannot use the limit law. So then what is my only option here? What could I possibly think of doing?
You're going to try to get together the denominator.
You can, but it's not gonna do any good. It's not gonna harm. So you want to do this. It's not gonna harm, but I'm not closer. It's okay. It's not a mistake. It's not illegitimate. It's fine. But what not? Unless I proceed with something.
Common denominator.
Yes, the least common denominator in brackets. I don't disagree with this. That's fine. But now I have limit t approaches 0 from 1 over t times, what is the least common denominator here? Good. And then what do we need to multiply the top of the first fraction by? Very good. So then I have t plus 1 minus 1. Now this is okay. It's good. So these two obviously go away. So then I have limit. Do not drop the limit operator. And then we have t over t plus 1. Good. I completely agree with every step. What do you think I'm going to do next? Say it again. Of course, because that is the problem. The factor that creates 0 over 0 is t. Good. At this point, I can drop the limit operator. What do I get?
1.
That's it. The limit is 1. Would you have guessed that 1 over 0 minus 1 over 0 would be 1? No, of course not. No one can. Good. Is this okay? Next question, anything you like. Five? What do you mean by 5? Okay, so that was D. We did A together. So this was limit as x approaches 0 from the right, from arctangent 1 over x. Okay, where do we start? Oh, the answer is with the inside. Where does this go? No. It's 0 from the right. No, it's not 0. Please don't say that 1 over 0 is 0. So here's the, oh, that's not good. This is the graph of 1 over x. When x approaches 0 from the right, this does not approach 0. Please, only if this is infinity, but that's not the case. We're not talking about infinity here. So then, good. And now I have to remember a graph of arctangent. Here's the graph of arctangent. Please remember the graph of arctangent. And then the answer is pi over 2 indeed. Okay. Last class, we just worked on this problem. I copied it from the book. It's the next problem. Watch, this is 5b. Limit of e to x minus x squared when x approaches infinity is 0. Because when x approaches infinity, this is stronger. It's negative infinity. And e to negative infinity is 1 over e to infinity, which is 0. So this is 5b from last time. We see that? Any questions on it? Any questions? Okay, very good. Next one. I think we did this one in class, but let me know if we need to do it again. I don't mind. Yes or no?
Yeah.
Yes, very good. So let's start with the absolute value, of course. The absolute value of 2 minus x, as we know, has two possibilities, two options. Two minus x for 2 minus x greater than or equal to 0, or the opposite of 2 minus x for 2 minus x less than 0. Remember, we do not solve this inequality. Do not waste your time. Whatever it's not here, it will be here. So when I solve this inequality, this one, I get negative x greater or equal to negative 2 or x less than or equal to 2. So I continue. The absolute value of 2 minus x then is 2 minus x for x less than or equal to 2, or negative 2 minus x for x greater than 2. If this is less than or equal to 2, this must be the other side, which is greater than 2. Are we okay so far? Is that a yes?
Mm-hmm.
Okay, now we put together 2 minus x over the absolute value of 2 minus x, and we know we're going to get two options. Can anyone give us those two options? This over this. This over this. So this now is this quantity in the denominator. What do we get? 1. However, we can no longer keep the equal symbol because now this quantity is in the denominator. So I have to write less than 2. Now, if this quantity is negative 2 minus x, what do I get as the final simplified form here? If this quantity is this one now. Do we all agree with negative 1? For x greater than 2. Now I go back to answer the question. The question was this. X approaches 2 from either side, 2 minus x, the absolute value of 2 minus x. I don't know how to answer, but because I have to find the limit from the left and the limit from the right. The limit from the right of what? And from which one I determine the limit from the left?
-1.
Yes, for the first one is indeed -1, and for the second one is 1. So what is this limit? What is this limit? So what is this limit? The limit can only be one number. It can be infinity, it can be negative infinity, or DNE.
DNE.
Ah, I agree with DNE only. Only DNE. If the left-hand side does not match the right-hand side, the answer is always DNE. Okay, we have limit as x approaches 3 from the square root of x plus 6 minus x divided by x cubed minus 3x squared. We plug it in, what do we get? Indeed 0 over 0, so what options we have here? Excellent. The square root of x plus 6 plus x, the square root of x plus 6 plus x. Awesome. At the same time, I'm going to ask you, without even looking, we plugged in 3 and we got 0 over 0. If this limit exists, which factor do I have to remove from the top, or which factor I have to remove from the denominator? Which is the factor that creates 0 over 0? So when I plug in a polynomial or in an expression, 3, and I get 0, that expression has a factor of what? We forgot the remainder theorem and the factor theorem. We have to talk about it. So, p of x equals x squared minus 1. And I want to find p of 1. What do I get? 0. Because x minus 1 is a factor of p of x. I want to plug in 3. What do I get? 8. Since x minus 3 is not a factor of p of x. I want to plug in -1.
0.
Good. Since,
Plus 1.
very good, is a factor of p of x. Awesome. So now I want the answer. I plugged in 3, and I got 0 over 0. Eventually, which factor has to go away from the top and from the denominator if the limit were to exist? X minus 3. Very good. Okay, so let's see how we get that x minus 3 out of there. First of all, can you factor anything here?
Yes. X squared outside of.
Good. And I have to copy this. Please remember, the reason I'm saying that is not because I'm going to test you on the remainder theorem, but it's a landmark, if you want. It's something that we should know. If this were to exist, it must be there. An x minus 3, then an x minus 3 from the top should go away. Now, I don't know if the limit is going to exist, because this may have 3x minus 3 in the denominator. Then if I remove one of them, I still have 2 left. So there is no guarantee. But obviously, at least one factor of x minus 3 with one factor of x minus 3 from the top and the denominator must go away for sure. Okay, so please multiply those two.
X plus 6 minus x.
Careful.
X squared.
Minus x squared. Very good.
Oh, right.
The first term squared minus the second term squared. Is this okay? Good. So let's continue. I'm continuing here because I ran out of room. It always happens, I know. So this has to be arranged in descending order as negative x squared plus x plus 6. I will factor out negative 1. And please give me the factored form. And you better say an x minus 3.
X plus 2.
See how powerful you are? I meant to copy x minus 3, and you said plus, and I just wrote plus. My goodness, just don't say jump from the Empire State Building, because I may do it. You're too powerful today. I meant to write x minus 3, of course. So at the top, make sure that there is an x minus 3, otherwise something is terribly wrong. Yes, so what do we have at the top? After we factor out negative 1.
X plus 2, X minus 3.
Very good. It must be there. Because I plugged in 3 and I got 0. A factor of x minus 3 must be there in both. So now, these go away. And at this point, yes, you can remove the limit operator. You can drop it. The top goes to negative 5. No, the top, we drop the limit operator. The top goes to negative 5. And the denominator goes to, this goes to, good. And this goes to, very good, because it's 9. The square root of 9 is 3. 3 plus 3 is 6. So this is negative 5 over 54. So now you see we can assume anything. Initially we had 0 over 0. It had turned into negative 5 over 54. Very good. Okay. And the last limit. Any questions on this one? If I plug in 0 and I get 0, which factor I expect to remove? X approaches 0, and I plug in 0 and I get 0. Which factor do I expect to remove from TOS? X, correct. Very good. Okay, so last one here, limit x approaches infinity. The square root of x squared minus 9 over 2x minus 6. No, we cannot rationalize here. We have to do something else. We plug in, of course, it's infinity over infinity. This is another indeterminate case. No one has any idea what this can come up with. I mean, can turn out to be. No idea whatsoever. So, and there is no rationalizing because these are not two terms. This is just one term, if you want. I shouldn't call it term because it's not a polynomial, but it's one quantity. Okay, so like we did before, we have to factor out the degree inside the radical. And I will also factor out the degree in the denominator. The degree in the denominator is 1, so I pull out an x. The degree under the square root is x squared, so it's 2, so I pull out x squared. Now I use a property of the square root. Do not drop the limit operator, please. Square root of x squared times the square root of 1 minus 9 over x squared divided by x, 2 minus 6 over x. Now remember, this is not obvious and it's not direct. It all depends on this, because it could be positive x or it could be negative x. But since x approaches infinity, what could that be replaced by? Positive x indeed. Very good. So then I write it one more time. X approaches infinity, x, the square root of 1 minus 9 over x squared over x, 2 minus 6 over x. And I do cancel these. Now I'm ready to drop the limit operator because it's final. The numerator goes to, yes, And the denominator goes to 2. So the limit is 1/2. This was infinity. Therefore, y equals 1/2 is the horizontal asymptote at infinity. Very good. Anything else?
Number
Yes?
6.
Number 6. Yes, use the intermediate value theorem to show whether the equation has a real solution. So we have 2x cubed minus 8x squared minus 7 equals 0. Sorry. And I'm going to denote this by f of x. And I will definitely say that f of x is continuous on negative infinity to infinity as a polynomial function. That's the first hypothesis of the intermediate value theorem. The second one, I have to look for an interval of 1 unit length, not between 0 and 10. Like, I don't know, between 0 and 1, or between -3 and -2, in which the function changes sign. But I have to use the graphing calculator for that. So in y equals, put in the function, and clear if you have anything else. 2x cubed minus 8x squared and minus 7. And then I'm just gonna, so there is no deep freeze on this one. Yes, okay. So second and table, and I go in and plug in some numbers. I normally start left and right of 0. Like, I don't know. I am cheating right now because I do have the graph right here. So I know that if I go to the left and right of 0, in vicinity of 0, I'm not going to. Sorry. I got over a cold last week, but now I have a tickle in my throat. Sorry about that. So I'm cheating because here I have the graph in this viewing window, so I know where the solution is. But let's say I don't see that. I'll start with -1, and then -2. And I see it's going towards negative. It doesn't approach the positive side. So then I'm going to say 0. And then maybe 4. Okay. And then 5. So between 4 and 5. At 4 is negative. At 5 is positive. That's all I need. So I'll say f of 4 less than 0. F of 5 greater than 0. From 1 and 2, comma, by the intermediate value theorem, IVT, there exists a C in the interval 4, 5, such that f of C is 0. You will see what we are going to do with this theorem in chapter 4, because the intermediate value theorem does not determine the solution for us. The next theorem in chapter 4 will. Any question on this?
That's f of c equals 0.
Yes.
Okay.
So there must be a solution between 4 and 5 because the function is continuous. It's negative at 4 and positive at 5. It has to go through 0 because it's continuous. Next question. Anything else?
Number 7.
Number
7.
7. Okay. Let's discuss about this or look at this graph for a moment. Ready? Okay. I see the function is increasing between this piece and this piece, correct?
Mhm.
I see at the top here, the tangent must be 0. The slope of the tangent, sorry. The slope of the tangent must be 0. Then the function starts decreasing between these 2 points where it has another turn and the tangent has a slope of 0 as well. And then it starts increasing. Remember, the derivative gives us the slope of the tangent line. So when the function is increasing, the slope of the tangent line is positive. When the function has a turn, either max or min, the slope is 0. Here the slope is positive. The slope of the tangent line everywhere between this point and this point, the slope is positive, therefore the function is increasing. Between this point and this point, the slope is less than 0, which means the derivative is less than 0. Between this point and this point for x. Between 5 and 15, the function decreases. Between 15 and 20, the function increases, which means the derivative is positive. So here, first derivative, positive. Here, first derivative, 0. First derivative, 0. Slope, or first derivative, positive. Slope, or first derivative, negative. That's all. Any questions?
So is that how we should write it for the answer?
Exactly how it's here. So f prime of x positive on 0 to 5, union 15 to 20, and f prime of 0 less than 0 on the interval 5 to 15. Is that clear? Do we understand this? Is this clear to everyone, please? Any questions? Please ask. Anything else?
For number 8,
Yes,
do we use the slope?
number 8.
Yeah.
Okay, let's take a look. So for number 8, we are given a function and a point. At this point, we are asked to find the equation of the tangent line. So since it's not the y-intercept, y minus y1 equals the slope times x minus x1, where y1 and x1 are given, but I'm missing this piece. How do I determine that piece? What do I have to find? Very good. I have to find the derivative of the function, and then what do I plug in it? Which is? Excellent. Perfect. I do not have any other method but this. Limit as age approaches 0, unless you want to use f prime of a, which is fine too. The square root of x plus h minus 2 minus the square root of x minus 2 divided by h. F of x plus h minus f of x divided by h. Of course, if you plug in 0, what will you get? No question. You will get 0 over 0. Which factor do you are anxious to get rid of then? Age, indeed. Age is the problem. Age creates 0 over 0. Awesome. So then you will multiply top and bottom of this fraction by x plus h minus 2 plus the square root of x minus 2, x plus h minus 2 plus the square root of x minus 2. Awesome. Do not drop the limit operator. Don't I sound like a broken record? My apologies. But I just don't want to see it because I have to, I cannot give full credit. Let's put it this way. If you drop the limit operator to the last step, please don't do it. Okay, so I'll copy the denominator. And can anyone give us the numerator?
X plus h minus 2 minus x plus 2.
Perfect. This is a difference quotient. Two things must happen. If not, I'm not on the right track.
Things not attached to h.
Have to go away. And eventually,
H.
well, okay, let's see. As expected. The next step, h with h will go away. Now I can drop the limit operator. Please give me the final answer. Bless you. Excellent. Very good. So one more time, this is f prime of x, which is 1 over 2, the square root of, oops, x minus 2. But I really want to determine f prime of 2. Sorry, f prime of 11, which is the slope I'm looking for. So then I have 1 over 2 times 11 minus 2 is 9. The square root of 9 is 3. So this is 1/6. We agree? So we go back to the equation. Y minus 3 equals 1/6 x minus 11. Let's take a moment and see if you have any questions, please. Anything? Is this clear?
Can we leave it like that on the test if you want us to say?
No, we have to solve for y. So 1/6 x minus 11 over 6 and plus 3. So 18 minus 11 is 7. Y equals 1/6 x plus 7 over 6. Any questions for me, please? Anything? Is there anything else you would like to look at? Anything?